Yeah, so like what are we talking about? So I started this by going, what are the buildings in question? And I could have written, covered a million pages with all the photographs. I took these from the National Inventory of Architectural Heritage. So you've got a large red brick, terrace building with a complicated bow on the front of it. You've got a small house, which has a shop downstairs with accommodation above. You've got a really interesting cottage here that's half cottage, half modern slate roofed house with different levels and obviously probably half different materials in it. You've got an end of terrace with a gable on the front of it, which is just different weird and wonderful things when you're talking about your insulation. You've got here a little terrace of before and after. You've got a template of what it should be like and what it could be like for the one next door. Here you got a beautiful ashlar stone building over a raised basement, so it's got a different floor plan, than some of the other buildings and different aspects to the building. A traditional cottage this time with a slate roof with different render exteriors and a lovely I love this one because it actually shows the original render on the exterior of the building on a rough stone building. So that's kind of like just a potted view of some of the buildings you're going to come across, and all the buildings you're going to come across are going to be completely different than this again. So you know what I mean? So you're going to have loads, and some of them may be in poor condition also, from starting out. So that's got its own issues. So with that in mind, we understand that this is different from modern construction. So the improving energy efficiency in traditional buildings, the guidance for specifiers and installers, um, is available online on government.ie, and this is the publication that all the illustrations I'm going to use come from. However, if any of you would like your own copy, I think we've had a new print run, so I think we could arrange, to actually send them out to the various one-stop shop, because I know myself, I love to have something to thumb through and have a look at. So we can arrange that if anybody is interested. I can give my contact details to Siobhan and Stephen, and we can post them out to you. So yeah, it's an overview to provide clear and robust advice, but it has to be strategic because, as I said, all buildings are not, they don't all look the same, but the good thing about it is they all function the same. So the function is the traditional construction. That's the function. The most significant element, I suppose, really is the solid masonry walls, and they can appear in different forms. The table on the left, I think it's actually in the pilot scheme guidance. Yeah, it just gives you an idea of the different types of construction you'll come across. The biggest thing to note is that it's a solid mass, a solid thermal mass of wall that you're dealing with, that there's no cavity, and mostly it'll be a lime-based mortar, often depending on the regions and the locations of often rural, you can have an earth-based mortar or render, and finishes on the buildings that you're going to come across. So these are the kind of telltales. A big thick wall is really the first thing to identify the buildings for this pilot scheme. They traditionally will have single glazed timber or metal framed windows, oftentimes with shutters for finer buildings, or without shutters, and splayed window reveals, which is a very good characteristic as well, which allows a lot of light in. So any of the elements of a traditional building have a function. Not that they also have a design element, but it's fundamentally it's a function element. So a timber framed roof, usually clad with slate, but you can also have tiles, copper lead, and in instances throughout the country, like one of the photographs I showed you up there, you can have a corrugated iron roof. And in that one, in case it was in combination with a thatch roof. So you've got all the various elements. But I suppose that's the distinguishing factor that we have. And this is a really useful guidance, even for discussions with homeowners, how it's different from a modern construction. A modern construction has standard details, standard applications for construction, foundations, and upgrade of insulations. Whereas a traditional solid masonry wall functions differently. It doesn't necessarily have your standard foundation as a modern construction, but does have foundations. And how that is actually borne out in the fact that most of these buildings are standing for 100 to 200 years. So if somebody comes in and goes, it's got no foundation, it doesn't need a modern foundation. It has its foundation inherent and built into its construction. So that's not necessarily an issue unless there were structural issues. So that's something to be considered when somebody says it doesn't have a foundation. It has different functions. For the most important function of a traditional building is because of its solid masonry construction. It's to allow to keep moisture away from the building and run off from the building. So the roofs, the gutters, the falls, the external falls, the internal floors, possibly at a higher level if they're timber or more fragile materials, that they don't suffer from rot and they have more ventilation under them. It's different if you have an internal stone floor or an earthen floor, they can actually be at a lower level because of the construction. And it's the most important thing is they are vapor open and allow the movement of moisture. So that's where we part ways with the modern construction. When you're talking about applications to a modern building, it's part of the whole, impenetrable construction. Whereas with a solid masonry construction, it allows for the movement of moisture and vapor through the structure. So therefore that has to be considered with any works to the structure, that you have to allow for that ventilation, you have to allow for that moisture movement, and you can't the application of non-permeable barriers is very detrimental to the fabric of the building. So, and that's where we start thinking about when we're talking about us now as retrofitters, upgrading buildings and applications to the buildings. So as Stephen was saying, I've just taken this short form of the traditional building professional is going to be your absolute, best friend and ally in this project. So outlined here are the 3 types of professionals that should be employed by the owner prior to actually going for the application process with the links below. But also I've included a link, table 4 of the IETB, improving energy in traditional buildings as short form. So it lists the other skills that you may need to take on during the project. For example, you will have the BER assessor, you could have a thermal bridge modeler, you could have a ventilation validator, air permeable tester. So they're all the kind of things that may be as an add-on to actually ensure that the uncertified materials are appropriate for your building. So they're an important aspect as well. So, okay. So yeah, also in the pilot scheme, I note that there's the flow chart of the process, the recommended procedure for developing a retrofit plan. And I'm going to just put it down here. It's a 10-point plan. So first of all is somebody wants to upgrade their building. They want to improve the thermal performance. They want to make it warmer. They want to possibly reduce the energy waste. But the step 2 from a traditional point of view for a traditional building is one of the most vital steps in the entire process. And it involves nobody going near the building or altering the building or putting a nail in the building. I know that's an old phrase, but you're not putting nails anymore. But anyway, do you know what I mean? Touching the building. So it's really important for the building traditional building professional to understand the heritage significance. Okay, that can be statutory heritage significance, or it can be just basically the actual fabric that is extant, that has been there for 100 years and performed quite well. Oftentimes you have issues with the condition in relation to lack of maintenance, poor maintenance, or inappropriate previous applications. So that's a very key element, because moisture defects are very prevalent in buildings where there's lack of maintenance or inappropriate, and there is no point in starting an energy retrofit program if you have a building with moisture defects. It's just like that's the first principle of the building. I'm going to go into this in more detail. I just want to run through the other elements of the scheme. So the 2 things I'm going to concentrate on step 2. So you've got to do your targets, your objectives, assess the measure, determine the risks of condensation, ventilation, and heritage impact. Very important, as you decide on the measures that you're going to actually apply to the building. from the grant ideas. You may need to appoint additional consultants depending on the condition of the building and any of the defects or concerns in relation to moisture or thermal bridging or interstitial condensation risk of applications. Create a shortlist then following that, which are the appropriate, and maybe some of the things you considered first of all may be inappropriate. You have to focus elsewhere or change the materials you're going to decide on. Revise your targets based on the considerations of that you've already had to take into account depending on the actual building. And then consult with the appropriate local statutory authorities, whether that be building control or the local authority conservation officer. And I'll just kind of cover that in the next slide as to what were the key elements you should think about. And then you're the suitable contractor. It's really funny that that's actually down there. And in this instance, the contractor is here from the beginning, but that's just the natural, the flow chart. And then basically implement the document and evaluate. And as Stephen was saying, the supporting documents, the SharePoint folders, I think are going to be a key element for all of us as a learning experience. These are like, it's a pilot scheme, it's a testing ground, it's actually to see where things are going to improve. And the more documentation we have, the more evidence we have for saying yes to this and absolutely no to the inappropriate things. And it'll make your life easier when this scheme gets rolled out long term and they say, this worked, we know this worked, we're not even going to waste your time or energy or going on using other applications. So that's really important for us and for you to ensure that the documentation, and I know everybody loves documentation, but it's very important that we all actually, consider that as part of the whole process. Right, so another lovely thing I'm going to talk about back in stage 2, the heritage impact, and also consulting your local authority. It's no harm to actually just go through. There are statutory requirements of a building, and then there's the technology, the traditional technology. So there are some traditional buildings that have statutory protection. They are either a protected structure, and for a protected structure, works that materially affect the character are considered development and require planning permission. For a protected structure, for example, this building down here in the corner, it's the exterior, the interior, the curtilage, the boundaries, and any buildings within that site are part of that protection. And any character elements of those are part of that protection. So that's a really important thing to do, to understand that it's the entire fabric and associated buildings that's protected. Okay, that doesn't mean if you've got a 1980s shed built in the backyard of a house, that's not part of the protection, and that's consultation with your local authority. I'll go into that, but just as a basic thing, it's either a protected structure where everything is protected until it isn't, is a nice way of putting it, or you have an architectural conservation area where the exterior character is protected. For example, if this is neither, by the way, this is neither protected nor in an architectural conservation area, that's building down here. But if this was in an architectural conservation area, what would be protected was the elements you could see from the public domain. Okay, so that's not just the front facade. In this instance, you can see the gables, you can see the outbuildings, you can see the side building, you know what I mean, in the yard. So they are part of the character. So it's not just the front elevation. So that's important one to say when somebody said to me, oh, it's just the facade. You can say, not so sure. Okay, so, and how you actually check to see this, every local authority's development plan has what's called a record of protected structures. And that's a list of all the buildings that are protected. And in addition to this, they have the ACA map viewer. So basically that clarifies if a building has statutory protection, and anybody can search those mostly online, the development plans. The map viewer, I'm saying it's the ACA is for a map viewer. Oftentimes, some local authorities just have a boundary around an area and it's buildings within that. that are considered part of the ACA. Other local authorities actually list the characteristics within that area, but it just depends. But it's just an idea that, first of all, your traditional building professional will have more experience in this, but it's just one of those kind of initial things of giving people comfort, and so that you're talking on the same page, on the right page. The other thing to consider is the record of monuments and places. This is often, we associate this with medieval buildings, with castles and ruins and so on and so forth, but it's actually in some local authority areas, vernacular buildings are on the record of monuments and places. So that's another part of the statutory protection that needs to be, checked, and get the homeowner to do this. You know what I mean? You can actually, if they come to a question, make sure that they know these things, because there's planning implications. Like I said, you might require planning permission, and it might slow down the pilot a lot more. If they might have considered as yet, they don't have their ducks in a row with their planning. So, and if in doubt, I'm kind of bamboozling you, you can contact your local authority architectural conservation officer. But not all local authorities have an architectural conservation officer. So in those instances, you can contact the heritage officer in the local authority. Okay, and they'll be able to answer those questions, because in those local authorities, they carry the function. So that's just the kind of the statutory requirements. If you have done your 8 steps before you get to the local authority in an appropriate manner, in some instances, you may not require planning permission. You may not be materially affecting the character if you're keeping the windows, if you're keeping the roof, if you're keeping the walls. So there mightn't be a planning consideration, but it's for major works. In certain instances, there may be a planning implication. So that's, it's just one of those steps that people forget about. That, and making sure that the building is dry, I think, is the first next thing. So yeah, and there's a lot of reading here on this one. It's kind of a snapshot of what would be appropriate for any traditional building. And then there are particular warning bells for buildings that are protected structures and in ACAs. I'm not expecting you to read this, but if the first one is to do with the outer walls. So I just look here. Internal wall insulation on walls without historic features. If it is not a protected structure, then it is compatible to put internal wall insulations. It's okay if you go down to the little table at the bottom, okay? But the one below it, it says internal wall insulation on walls with historic features. As you can see, it's got a red, okay? Because from an architectural character point of view, you're going to lose all those features if you put internal wall insulation. A nicer one, if you go to windows, I like to do the positive ones. Optimizing of traditional windows, repair and draft proofing is green, and then installation of secondary glazing is a lighter shade of green, which is part of the pilot scheme grant funding. The reason it's a lighter shade of green, sometimes when you put in internal insulation, unless you have it slim enough and you had shutters, you wouldn't be able to close the shutters. So that's a material change. You're losing the function of the shutters. So basically, if you can do it, it's a slim enough insulation that you don't lose the function of the shutters, then it's compatible. Do you know what I mean? It's generally compatible. So that's just a good kind of a snapshot. And I would be pointing homeowners to this to actually make sure that what they're thinking about and what they think they can achieve from the scheme is appropriate from the building as well. It's a good a checklist. So like I said, harping back to the dry buildings, as part of the condition assessment, if you don't have a dry building, it will be very difficult for a homeowner to progress in a timely manner with upgrading works until they address the moisture elements of the building. So that's a really important thing for you to actually drill home to anybody who's inquiring about the scheme that they have to leave time for, drying out of the building. So it should be in good condition, free from excess dampness. And in good condition just really means dry. It doesn't mean like that can be a room. A room can be in good condition if it's dry. A vacant building can be in good condition if it's fundamentally dry, if the gutters are working and the render is functioning. The building on the left there has a cement render on the exterior of it. That's why it's not functioning very well, because it's got a complex roof system with lots of gutters and lots of moisture overflow. So it's actually quite damaged. The building on the right is actually a 17th century building and hidden under a load of cement, inappropriate render. So that's actually derelict and damp. If that didn't have the cement render and was just derelict, it could be a dry building. So it's very important. And the only other thing, traditional construction is vapor over, so should the retrofit materials, so that it actually uses the thermal mass of the building appropriately. Okay. Yeah. I don't know. Am I obsessed with wet things? Probably. I really like this. This is a very important.
You're in a good country then, Carl.
Yeah, I know. It's just like we would all be out of a job if we manage wet, weather properly in this country. So like rainfall on the wall surface. When I saw this chart, I was kind of blown away, to be quite honest with you. Proportionally, the relative wetting mechanisms. Rainfall is the biggest wetting mechanism, in a building. So appropriate removal of rain from a building is the best thing you can actually do, followed then by gaps and vapor permeable construction. So vapor permeable construction is an issue, but if you don't have the appropriate weather screen on the outside of the building, you know what I mean, you're at nothing. You know what I mean? That is the most important thing, to make sure that it's dry. And also that's where all your heat is lost in a wet building. So from the just drilling down into the various elements, you're going to come across all the different shapes and makes of roof types, and what's appropriate, where the warm areas isolated from the cold area of the roof. And but the most important thing is whatever system you apply, that it's integral, there's no breaks in it, but it also has to always integrate appropriate ventilation. So I've given just some examples of the ventilation types that would be appropriate. This is probably more key for like a protected structure or an architectural conservation area, but they're also very simple, straightforward, off the shelf, solutions for any traditional building to incorporate your ventilation. The last picture here is just a wee picture of parging, which is a traditional windproof membrane. It's just line render on the junctions of the slates. Oftentimes you can have it buttered on the whole back of the slate as well. So as part of the heritage impact and the condition assessment, the existence of this should be noted and considered for any further insulation upgrades. It's part of the original character, it's part of the function of the building, it's part of the building technology. So it should not be just, don't throw the baby out with the bathwater. So yeah, you've seen these illustrations before. They're not prescriptive, they're just indicative of the level of insulation that can be achieved, and the importance of always considering the ventilation routes. The slide on slide 32, you can do a combination. It's on the right. See, I'm not going to do this. I'll always do this backwards. The one with the parapet, you can view that as a parapet, but if you put your hand over the parapet, you're back to what a traditional roof would be like in, for example, a farm building, with the room extending up into the ceiling. So you can do a combination of, this combines different ventilation paths that are required. And in some instances, you will lose elements of the internal fabric. For example, that plaster, if it was a Latin plaster on the ceiling, that would actually have to be taken off so that you can ensure that you can get the insulation into the ceiling that's proper. So that's a minimal intervention. It's a minimal loss of fabric. It's justified. It's okay, because actually you get a proper integrated insulation into the building. So that's more appropriate. Similarly with the picture 31 on my left, In this instance, the roof level has to be raised. You can see an old dotted line where the roof was to allow for the insulation to be put underneath the roof. In certain instances, if it's a protected structure in an architectural area, that may be considered a material alteration, but consultation with your local authority conservation officer, you can actually decide. In this instance, it may be a minor alteration and it may not necessarily require planning permission, but that needs to be asked and assessed. From a floor point of view, I'm just going to just draw your attention to the instances for the integral fabric in the building that functions in a way at the moment. So therefore, it may not be appropriate to remove this stone floor here on the left. Too much of a loss of fabric, and it will never actually be very difficult to lay that floor again in the same manner. So in this instance, it may be not appropriate to address insulation or upgrades of floors. Whereas the middle slide is a timber, suspended timber floor. It's a detail of a floorboard. You can lift the floorboards to actually put insulation underneath, but just to be aware that certain floors are laid differently. In this case, it's got a biscuit joint. It's just that little small little vertical piece of timber that butts between the two timbers. So it's not just the same as lifting a tongued and groove floor. More consideration has to be made, and that's all part of the original assessment of the fabric to see what the heritage impact would be. And on the far side with it's actually not a Sugon chair, it's just a timber chair. That's an earthen floor, the original earthen floor. Now, everybody will run a mile when they see this, but it may not be worth. The thing is, that has integrity. That actually has a function. It is a good moisture wicking element of the building. It addresses moisture levels within the wall. So if that is a functioning floor, consideration to retention of that floor. It's not a case of, oh, that's an old earth floor, we must rip it up. It actually has to be assessed. The condition of it has to be assessed, the integrity of it assessed, the function of it. If it retains its function, maybe in this instance, it doesn't need to be taken up. In other instances, you may have an uninsulated concrete slab, and in that case, it may be more appropriate to take up the slab and actually put down an insulated slab. Here is your detail from the guidance again. If you have that timber floor that you can take up, ideas of the construction of the membranes that you actually need, the vapor permeable, the wind tight vapor permeable membranes in blue below the insulation, hung over the rafters, and then an intelligent vapor control membrane laid on top, and then relaying of the original floors. And that's actually a very important system, because we have had instances where people didn't adhere to the intelligent vapor control membrane on the top, and there was a rot and moisture and damp on the underside of and also a few mushrooms on the underside of the timber boards as they were relayed. I just wanted to, windows is another element. It's part of the grant. We're delighted to see that secondary glazing is part of the pilot scheme, because just looking at these windows, I can just say to them, on average, these windows are 100 years old. They may look a bit shook, but that's because they need a lick of paint or need a bit of ongoing maintenance. Fundamentally, their integrity is very good. Over the years, they would have, from opening and closing them, drafts would have come. They need to be oftentimes rehung and, the weights rebalanced. And the introduction of a secondary glazing will upgrade these windows to modern standards. If there was an option of secondary glazing in their day, they would have used it. So there's no reason why we can't just apply these to perfectly good functioning windows. The windows there on the all stacked up or taken out of a building. They were in the building for over 100 years and were just removed without consideration and replaced with windows of an inferior quality. So I just wanted to put this. I'm sure you've seen. I always trot this slide out. In the skip, you see a load of windows on one side. Actually, all those windows are PVC and aluminium windows. They have a life of 20 years. We're delighted that this scheme understands that the existing windows in buildings have already had a life of over 100 years and can be imminently upgraded to modern standards. So, for example, they're so good that you can actually use the original timber shutters for structural integrity in a skip bag. Just to show you, there's absolutely no reason why those windows should have been put out. So it's a kind of an idea about, not only are we talking about energy upgrading, we're talking about keeping materials, the embodied carbon, sustainability, repairability, all of these elements, circular economy. It's actually a much better to actually use what we have and upgrade them appropriately. So it's great that the secondary glazing is part of the pilot scheme to actually ensure that these windows can be retained. So yeah, similar. This is the shutter. I've put in the shutter idea, like I said before. In this instance, if you can put a secondary glazing panel on the inside of that window while still maintaining the function of the shuttering, that isn't considered material alteration. It's an appropriate upgrade. In certain instances where this isn't original glass, a double glaze unit, which is also part of the double glazing, is part of the pilot scheme as well. I'm sure that's right. Yes, it is. Yeah. So the double glazing, if there isn't the original glass. And here on figure 48 is just a very slim, like I said, you can do slim secondary glazing. It's very discreet. You can do them in aluminium, timber, or plastic. It doesn't matter because that's just the framing, so long as they're appropriate to the window type. And I just put in the middle one because there is an allowance towards doors. So the possibility of doing a secondary glazing or upgrading the glazing, double glazing in this panel over the door is also a consideration, which will vastly improve the thermal performance of that opening. Everybody is part of the scheme. I know there's internal and external wall insulation as a consideration. It's just really important, like I said, that it does have an impact on the building from the technology point of view, whether or not it introduces more moisture. So that needs to be clearly understood, the function, the structure of the wall before any application is put on. Also, if there's any historic fabric extent, as you can see here from the photograph, there is no details left on the interior of that building. It's really hard. I couldn't tell you. Well, actually, I can see brick outside. It's very hard to see what even the construction of it is. It's completely masked by the internal insulation. But it's important to know. So we just tried to kind of in the instances where it is appropriate, we've just tried to tease out how you actually address, for example, a difficult situation as in the window openings, you know what I mean? So there's a little diagram there that shows how this can be addressed, and replanting of skirting boards and different thickness of insulation, which is quite similar. But it's all, as you, the difference in this, it's all on the hard. The insulation is applied straight onto the masonry. There's no gaps in between. That's an important consideration. Similarly, you'll know this yourselves. It's all the devil's in the detail. It's the integrity of the insulation the whole way through the wall, and that's just a similar, photograph showing you that detailing. And it's how, like for example, existing floorboards and skirting boards can be maintained and replaced if this system is to be considered. And I just wanted to fly back up to this one. Oh yeah, actually I haven't included. Sorry, there's another in the insulation of the walls. There's another detail where actually the cornice is left at the top of the wall and the insulation is feathered up to it. So that's another idea that actually can, for maintaining, if there is an existing cornice and the decision has been made to put in internal insulation of the wall, there is a detail showing how you can actually retain the cornice and replant any picture rails on the insulation. So yeah, so I just wanted to, with external wall insulation, I just wanted to highlight a few instances. The building, the red brick building here, was actually a protected structure. Okay, so the top photograph shows the insulation applied to the wall, and the bottom photograph shows us having intervened after enforcement proceedings. So nobody wants to see that. Nobody wants to get to that situation where this application is being put on. So it's really important to understand the building and listen to the advice of the traditional building professional and liaise with the local authority to ensure that the appropriate measures are being applied. The building with the return is not a protected structure. So there are instances where external wall insulation can be deemed appropriate if the correct technical details have been adhered to, but just to understand that it does have a material alteration, and it may be a case that you require a declaration of exemption from your local authority to do this in a terrace situation. This is on the rear of a terrace. If it was on the front of a terrace in a red brick setting, it may be considered that you'd need a declaration of exemption. But that's all can be inquired from your conservation officer in your local authority. Yeah, I've just thrown this one in. In often cases, it's the weather coat instead. Maybe it would be better to ensure that the person renews the weather coat on the building, and that you focus the upgrade works and the pilot scheme to other elements within the scheme and leave the functioning weather coat to expel that water, that large bubble of water that I had in the diagram earlier from the building. And the thing is, all of these things, whether it's protected or not, the building regulations completely acknowledges the understanding that traditional buildings perform differently. So this is an extract from the technical guidance document L. Okay, it says the application may pose particular difficulties for habitable buildings, though not protected structures or pose protected structures. So it understands, for the statutory protection, it does pose difficulties, but it also understands that all traditional buildings, by their nature, they have architectural and historic interest, but they also, as a whole, have a permeable fabric which absorbs and readily allows evaporation of moisture. So your aim should be to upgrade it as best as possible, but not cause long-term deterioration of the building fabric. And that's really all we want. Looking at pretty buildings is one thing. We actually want functioning buildings that contribute to, reducing our carbon footprint and reducing, our energy costs in an appropriate manner, and also spending state funding appropriately. So that's me. I've just thrown in the two lovely slides again. These are there's chapter 4 in the advice series covers all the elements of heating and energy upgrades and the different considerations for a building. So that's quite an involved chapter. So I've just put those in just as an idea that it's an appropriate architectural conservation is a protected structure can have solar installations put them. They may require planning permission to do that, and then most traditional buildings have an exemption and can have solar installations on the roof, and they're a very appropriate addition to an already upgraded building. So, and I just threw in at the end for your information, for more reading, in case anybody needs more reading, on our website as well. In Buildings of Ireland, we have a whole list of advice series for people on the different elements of the buildings. The improving energy efficiency concentrates on energy upgrades, but these guidance give you the basic bones of the building construction technology. Thank you.